Welcome to our lecture online, and now we're going to look at the phasor diagram with respect to having an inductor in the circuit. So here we have a voltage source driving a voltage at a sinusoidal, with a sinusoidal methodology, and we have an inductor in the circuit. So what does an inductor do? An inductor opposes a change in the current. So as the voltage source tries to drive current through the circuit and builds up the potential across the inductor opposes a change in the current, holds back the current, so voltage builds up and current follows later. So in this case, voltage will lead the current, and that's what we have here. The voltage leads the current, but it leads it by 90 degrees. If the only device in the circuit is an inductor, there'll be a 90-degree phase difference between the current and the voltage. So when the voltage reaches its maximum value, the current is therefore 90 degrees behind in its process, in its build-up process. So here you can see the phasor diagram where the voltage is ahead of the current by 90 degrees. So as the voltage and the current go through their phases, you can see that they always will stay 90 degrees apart from one another. And you can see that here in this case, the voltage is building up. As the voltage is going this way, the voltage is building up in the negative direction. And as the current continues in this direction, you can see that the current is diminishing in its positive direction. So on a diagram like this particular situation lines up pretty well with the red line right here. You can see that at this point, as time goes on, the current is decreasing down to zero value, which is what would happen here. The current is going to decrease down to zero value as the phasor continues to turn to this position right here. And you can see here that the voltage will reach a maximum negative value as the voltage continues on over here and then expands to its maximum negative value over here. So this line right here represents as a time snapshot, and that's represented by the phasor diagram there. So that kind of helps us understand what a phasor diagram does. It really shows us what's happening, what particular moment in the phase we're at, what the phase difference is between the voltage and the current. Because now you can see a pictorial. As these things turn around, you can see that they represent the value of the current and the voltage at any point in time, and that's done using the phasor diagram like that. At least in the case of an inductor, that's what it would look like. With an inductor, we can see that the voltage leads the current by 90 degrees, and that's how we do that.